Okay, so class, good day. Yeah, it's 12 o'clock, and so we need to really speed up a bit. We spent 30 minutes introducing ourselves. When the lecture is over, use the same link, and then you'll be back, you know, in the class. Is that okay? We will use the same link to regroup. Okay. So GIS, I don't know if anybody here in the class has actually heard about GIS before, but GIS actually is a very interesting topic in a lot of areas. There are so many areas, fields of study that actually make use of GIS. Geologists use GIS. Engineers of all sorts actually use GIS. Are you okay? Geographers think that GIS is actually their thing, is their main thing. And so we are here to understand the principles and, of course, to see how it can be applied to civil engineering. Okay, so it does get interesting, and I always keep telling people that when a professor, someone who is specialized in an area, sees something is interesting, it may to another person, a novice, sound more like it's complicated, are you okay, or it's difficult. So I want you to take interest in the lecture and then follow as we go. So geographical information systems, are you okay? The three words, we need to really understand them. Okay. We're going to learn about the principles, basically. We want to understand the principles of GIS, and then having understood that, then we will go ahead and apply it. So in this introductory lecture, I want you to just understand what exactly it is, because sometimes what you think it is may not be, because you have seen someone using it. It doesn't mean, that is what is expected of you. So that in this course we will try and understand that you have to refer to books. Okay, when you're giving a lecture note or anything like that, don't just look at the lecture notes. Try and read from other sources. Go online, type principles of geographic information systems. You may get some free books on there that you can use. Also, I'll post any materials that will help you also on the lemma system. Okay, which I'm still trying to really understand, because I've not always been teaching at AIT. Okay, so there's a book by Paul Barrow, there's a book by Paul Longley. They are all very good books. Okay, and so you can make references to these books. Okay, but do not, please mute your mics, otherwise I have to mute you. I think I'll have to mute you actually, because apparently you are not going to mute yourselves. So let me, I can hear, I think it's Ivan. Yeah, okay, so I think Ivan is muted now. Yeah, all right. So please, well, the lecture notes, everything I'm giving you really constitutes that. Okay, and then the lab or practical work, we'll be using the QGIS in this particular, lecture. QGIS is a software. There are other software that are used in GIS. So we can have QGIS, okay, which is actually Quantum GIS. Okay, so this is the software that we'll be using, right? So I want you to take note of that. Quantum GIS. Meanwhile, there are so many GIS software. ArcGIS, MapInfo. MapInfo is used by geologists to do drill holes and to understand, the ore body. Maybe you don't know what ore body is, but those who are into mining appreciate it very much. It's okay. There are a whole lot of them, so many of them that I've only kept 3 in my head. That sounds very ironic. Okay, so please use the internet very carefully. Okay, do not just go on there. In fact, if you are asked a question in any exam, that any question that I ask you, the answer to it from online with me is likely to be wrong. That's how sad it is. I have to say that, because people just go on and then copy all sort of stuff. GIS stands for Ghana International School. Are you okay? So please do not copy wrongly. Is that okay? Just be guided what you're actually picking online. Okay. All right. So now, geographical information systems. You can, the keywords are really geography, information, and then the system. All right. The idea of a lecture is to let you understand what is geography. Geography, itself, you have to understand that information has to be understood. People call a whole lot of things information. That is not. What is a system? I mean, everybody should know what a system is. But that is what the idea is, really appreciate the words. Once you appreciate the words, you always know that there's a course you are doing, and this is what it's really about. Geography is really about the earth, are you okay, and the things that are on it. In other words, everything. So as we are even having this lecture, look around you, or if you could stand on your rooftop, or imagine standing on top of your rooftop, everything you are seeing, that's geography. What they are, whether there's a mountain in your vicinity, your neighborhood, whether there's a river pass, whether there's a lake nearby, that is geography. Are you okay? All right. So the lands features human beings. Yeah. We have. In fact, there's this interesting movie. They call it Apocalypto. So it's very scary and interesting and scary at the same time. And when you actually Google and try to find out the basis for that movie, then you realize that there were a group of people, who used to live in a certain time period. Are you okay? And where were they? You understand that you need to really find out. Maybe present day Mexico and all that. So geography is interesting. And I keep saying that a lot of politicians they really know some geography, because they can talk about the country in an interesting way that you want to just listen. Are you okay? But you hope that you don't get deceived and misled. Yes. So geography is not only about the people, animals, trees, things that you find on the surface of the earth. It's also about phenomenon. Are you okay? Which means that when there's a fire, yeah. In fact, I think in Australia, and then I think also is it Canada also, like Australia, I think so. They have, and US, some parts of US, on a yearly basis, you always have fires, wildfires that I just keep asking myself, how come a whole country, developed advanced country like that, and they keep experiencing such a phenomenon? And fires are phenomenal because it's not an object you can hold. You can't say this is fire. Are you okay? It's kind of spreading. Where is it? Where did it start from? Where is fire? Can you really? Has anybody caught fire in their hands? Are you okay? People try to swallow fire in some kind of gymnastics. Are you okay? And yet, phenomenal example of phenomena are clouds moving around. Are you okay? Flowing rivers. Are you okay? If a river is flowing, it's phenomenal. Are you okay? It's changing. It's like an object that you can't really figure out where exactly it is. Are you okay? All right. An activity on occurrence, as the slide actually says. So geography, in summary, is really talking about places, spaces, locations, people, objects all around you. Are you okay? So geographical information. So if we actually look at it, then geographical is like an adjective describing information. Are you okay? I'm not teaching English language. I'm just trying to let you appreciate what GIS is really about. Are you okay? So in this picture, you can see we have clouds. Okay, and this is what you see if you fly a lot. If you actually been an airplane before, then you realize that the clouds are not really that far up, because we've all imagined growing up that the clouds are really far up there, but they're that low. Are you okay? All right. So, but then they are phenomenal, Andy. One moment you have the cloudy skies, one moment you have a clear sky. Are you okay? And architects, have a way of really describing the sky in an interesting way. There are different settings. Are you okay? All right. So here we have a still lake. Yeah. Quite phenomenal. Well, nothing is really moving, but we can really compare that to a river that's actually flowing. Okay. Now, when you look at this place, okay, then you can see we have some kind of fishing harbor with people, and I'm sure people are there to buy fish, some are there to bring fish, okay, etc. Okay, so there's an activity that is going on, and so geography is really about that. It's about places, it's about going somewhere. If you're a tourist, if you like to really go around, travel the world, then geography becomes very interesting. But it's also interesting to you as an engineer because you don't live on the moon, do you? Okay, and that's why I want to see how, you know, the application of this geographical information. Okay, so we're going to talk about information in a bit and what it is and what is not. Geography, location. Let's talk a little bit about location. So if you don't understand location, or let me say elevation. So location, where is Kofi? Are you okay? And then someone say he's in Kumasi at the moment. That is location. Are you okay? Now elevation means okay, he's high up. Are you okay? If someone is really high, they may not necessarily be. You can have two people at the same location, but then at two different levels in terms of location. Am I the only one left here? Okay. Israel. I think, okay, we still have Nanaya online, if he can even hear us. All right.
No, sir.
Yes. Let's carry on, Israel. Let's carry on.
No, sir.
Okay, that's fine. Let's carry on. Okay, so geography is about location or elevation. So Ghana lies between latitude 4 degrees and 11 degrees north of the equator. It's telling you, it's giving an idea, you know, where Ghana is in terms of location. Now, saying Ghana is a lowland country is a totally different story altogether. As opposed to, there's a place in Asia called the Himalayas. Are you okay? And we have places where it's really mountainous. Are you okay? And in fact, you can even compare the mountains. In Ghana, there's an area in the eastern region called the Ekwapim area. And in the Ekwapim area, you always have, you know, a very mountainous area. It's always, you don't have flat areas. It's full of rocks as well. And then the Kwawu areas as well. So depending on where you are, you can describe it in terms of your location or your elevation. Is that okay? All right. So let me actually switch screen as I talk about location and elevation. Let me see if I can show you.
You have Pim Togo ranges.
Exactly. You can talk about that. I don't want.
Hello?
Yeah, exactly. That's good. That's a good one. Israel, yes, the Togo ranges and all that. Yes, you can talk about a whole lot. Yeah, a way to describe the terrain and the topography. Are you okay? All right. So that is good. I want to show you Google Earth. I don't know how many of you have actually used Google Earth before, but it's a very good way of actually looking at the earth. So I believe you can see the round earth being shown on Google Earth. This is a web application, so we can literally see the earth. Are you okay? Where's Africa on this one? This one is Asia. Okay, this is almost real. I mean, okay, this is like how the world looks like, and you can even see the stars in the background. But we are interested in just the surface of the earth. That's Africa, and we can zoom to it. Okay, we can actually, see the different regions. Okay, so now at this stage, this is what GIS is about. You see, the names and tests that you are seeing, annotations you are seeing, are actually giving us an indication where Nigeria is, for example. And we can also see where Ghana is relative to Nigeria. In between Ghana and Nigeria, you have Benin in the Togo. Yesterday, I sat in a taxi, and the taxi driver was actually telling me that he's actually been to Nigeria before and etc. And then he was describing how Nigeria is actually set up. That is what geography is about. I don't want to go into a lot of that, but I want you to appreciate that geography is knowing what is happening around you. Objects, phenomenon, all that contribute to your geography. Okay, so let me look for a place in this. So I'm interacting with the system. So in fact, this even summarizes what GIS. I'm looking for Medina, and then the system kind of takes me to the place. That is what GIS is really all about. So now you can see that I'm having a view, a kind of a 3D view, bird's eye view of where I live, where I'm talking from at the moment. I'm in Medina, and it's raining as well. Okay, so it's very easy to really talk about geography. It's everything happening around you. Okay, now I should be able to go closer. Okay, and then look at what is happening there. Okay, so here, this is the church I attended this morning. Are you okay? Now, isn't it interesting? What are some of the things around the area? I can see there's another church there. There are loads of buildings. Okay, okay. I Zoom just gave me an information that I don't have a 40-minute limit, and okay, I hope that is true. In that case, we can talk and talk and talk, and then we can even take a break and come back. But basically, you can see that I can just get to know what is happening in my area by using a system like this. Are you okay? This is really a geographic information system. All right. And there's more to it. Please don't think, oh, this is it. We know it. So what are you talking about? Don't how come some people didn't really understand what I was talking about in previous lectures? So pay attention. All right. So the geographic information system allows you to really know what is going on around you. And when I went to Kumasi, where I lived, I actually got to know that there was a lake behind a certain like mountainous place area. Meanwhile, I never knew that there was something like that there until I actually looked on a map. Are you okay? So maps have been digitized into systems. Are you okay? Or let me just say geographical information has been captured into systems that we are calling geographic information systems. All right, and which we want to know about. All right, so if you are on the same page, then I would like to go back to where I was to my PDF. Okay, so that is what geography is all about. Location, 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 elevation as well. Okay, so we can look at the elevation of a place. What about information? What is information? Information, okay, I think maybe I should be asking you, but I already shown it on the screen, so it's too late now, isn't it? Yeah, information is really not data. You hear people saying that I'm going to collect information. Are you okay? What are you going to collect information for? That means you don't even know what it is. Okay, you are collecting data. You can't be collecting information. Okay, and then you hear people saying that where is the data? Go and show it on the screen. It's your time to present. Go and show us the data on the screen. Maybe it's information he's talking about, but it's all kind of mixed up together. Okay, at the end of the information should make sense, and information actually comes from data. It's very important for you to know that. Information comes from data, and information is very, very important. Why? Because if I told you that red, if I said red, it wouldn't make sense to you. When I say blue, it doesn't make sense to you. But these are data elements. They are pieces of data. Are you okay? All right. And when I say one, it doesn't make sense. When I say two, it doesn't make sense. When I say you have two kids, now it starts making sense. Are you okay? Because now that's information, that's data being processed. And what the computer is actually doing is that it's virtually taking data in and it's actually converting it, transforming it into information. Are you okay? So an information system should, build on data. In other words, we need to get data first before we can deal with information systems, which computers allow us to access. I hope all that I'm saying makes sense. And you're also making little notes for yourself. So information is important. When I tell you your red car is on fire, that's information. Are you okay? But when I say red, it didn't make sense. You did it. When I said a car, it didn't make sense to you. But when I started putting them together, now it makes sense. It's been processed. data has been transformed to give you that. A system, I don't need to even define what a system is, but basically a system really is made up of parts. So a sound system, okay, allows you to listen to music. It's made up of the speaker, it's made up of the IC integrated circuit, it's made up of the capacitors, resistors, and all the things only for you to hear a sound. Is that also? When you buy a very nice sound system, what do you do with it? You just lay down, close your eyes, and listen. You don't even care how nice it looks like. What you were looking for was sound. But when you look at the things that went into it, the circuitry, it will amaze you. Okay, so that is the system. So in geographic information systems, there are parts. So we need to understand what the parts are. Are you okay? All right. Why is GIS really, where did it come from? GIS has not always been there. Are you okay? GIS was like something that people were proposing. Are you okay? People were like, okay, there could be something like that. There could be a system like that. But really, people loved GIS because of the lack of ability to track what happened in any business. Most of the time, you didn't even know what had happened to your car that is actually supposed to be conveying goods from Accra to Tamale or from Lagos to Kaduna. I don't even know where these places are. But there is a need to track activities. Okay. And so for businesses to be able to thrive, for managers to be on top of their game, they need to know what is happening. Are you okay? You just can't employ people and send them out there, go and sell for me, and we don't even know where you are. And that is why typically when you look at Uber, Uber has come in to just make taxi drivers look so sad, isn't it? Because Uber is making use of GIS. And now they know where the driver is. You can't run, or you can run, but you can't hide. Are you okay? And it's interesting. In fact, yesterday when I picked the Uber, in fact, at the point, Uber sent me a message that what's happening? You seem not to be moving, but because we're stuck in traffic. That is the kind of place that we're trying to get to with technology. We're trying to track and know what is happening. Are you okay? So they said there's so much gold in Ghana. How much has the white man taken away from Ghana? Excuse me to use that word. This video will go on YouTube, but yes, I mean, I'm not using white man in the sense of hate, but I'm just saying it because we just sometimes don't have the information system. We don't have the data, we don't have the information, we don't have the system. Everything that's happening is happening somewhere. We need to just know. Are you okay? Everything that's happening actually happens over space. Everything that happens is happening over space. It's not happening in a vacuum. Are you with me? And knowing where things are is very important. If you don't know what is happening in Kumasi right now, and you say you are really in charge of Kumasi, I'm sorry. Are you okay? You don't even know how many trees have been cut in
Yes, sir.
Kumasi. And you seem to be, you don't have to talk, please. You seem to be in charge of Kumasi, or the mayor of
Hello.
Kumasi, or the, please don't talk. The lecture is ongoing. So we need to know where things are. It is very important. It is very important. So I'm trying to mute someone. Don't talk.
Hello.
I'll let you ask questions, but don't talk. So
Hello.
it's
Hello.
okay. So I'm trying to mute someone. I don't know why the person is not even muting. All right. So yeah, let me carry on. Humans are limited in solving problems. So GIS is like a panacea, it's a solution for all of us. Okay, GIS is in there to help us. Humans are limited. Solving problems becomes very difficult. We can't sit down and find out, okay, I have 3 cars. There are 1,000 people who want to use a car. Which one of these 1,000, which one of them is actually closer to, or how the nearest 3
Hello.
people? Don't, please, who is saying hello? Can you just Try and connect. Don't talk, okay? Straight. I'll record it and send it to you. Next time, try and connect well. Is that okay? But for now, don't talk. And like, is it Israel? Israel, you just, I can't even mute you. What's happening? Hmm? You are talking to. The lecture is ongoing. Please, you join. If you can't join, find a way to join. All right. So, Nanaya, Ivan Mensa, I see you. I see everyone who's online. And please, let's continue. No need to be wasting time. You need to understand. That's the essence of a lecture. Do your best to connect and then to listen. Is that okay? All right. Excuse me. So GIS is very important because you want to take charge even of your own room, yeah, even your own house. You need to. You wish you knew. We could pick a laptop and know where things are in your house. Just Google, where are all my socks? Are you okay? Where are all, you know, but sometimes you can't even track. Are you okay? You just can't know where things are in your own room. So how much more when you are really in charge of a larger area, then becomes an issue. Are you okay? Then it's like looking for
Hello.
a needle in a haystack.
Hello.
So in the military, GIS is used. How is GIS used? They need to deploy equipment, and military equipment, you know what I'm talking about. They have military cars, military vehicles. Excuse me. We talk about expertise. They may need a radio, the person in charge of radio to be at a certain location. They may need the general to be at a particular area because you don't need the general doesn't have to be killed. They have all sort of battalions and companies. Are you okay? And how do they deploy? Where's the enemy? Are you okay? So where you pass is very important. So GIS can be used to track their where they are, that kind of thing. I think basically that's what GIS does. Are you okay? And so GIS is very important to the military. They're not gonna joke with it. In fact, I've seen job advertisements for people who know GIS in the military. Are you okay? Who are specialists. I mean, I'm not talking about the kind of GIS that you are learning in this class, which you are still trying to understand the basic principles. In forestry, trees are being cut everywhere. But the funny thing is that you can't actually go to the forest and be sitting there waiting to see who is cutting the tree. And say, okay, someone just passed over there and they are going to go and cut a tree. Are you okay? What you really do is that you have a way of capturing the data in terms of what is happening with the forest, which part of the forest is vegetation, and which part of it is actually bare, which part of it is okay, built up, etc. Which areas are like that. Then you can, over time, you can compare the images, and then you can tell
Hello.
that it's being
Hello.
cut here or it's being cut over there.
Hello.
Wow, do you know that all this while I wasn't recording because of the back and forth? So I don't know which part I've missed. Okay, so this will be the outline. We talk about definitions and concepts of GIS. So we want to know what really GIS is about. Are you okay? Data sources. Where do we get data from? Without data, there's no GIS. Are you okay? All right. We want to also understand how the data is acquired. How do we get it? How do we get it? So remote sensing, photogrammetry, things like that will come in. Methods of data inputs, you have to digitize existing hard copy maps because GIS really works in a digital environment. We are making use of what? Computers. Is that okay? All right. And data structures and data models. Once you are collecting data and it's not well structured, then you cannot really, we want to understand how GIS models the data. Is that okay? Data has to be modeled. we all know that when you are constructing a road, the center line is supposed to be straight. But sometimes when you look at certain road, you wonder if the design was having the straight line as a center line. So I want to tell you what modeling is about. That models are really like mathematical. Are you okay? We should be able to now rigidly say that this is it. Yeah. Okay. So we talk about network analysis. Like I said, how GIS is applied in a road network situation, for example. Okay. What are some of the things we can do on a network? All right, a road network. So we discussed that. Okay. 3D surfaces are very important if you want to understand like where to cut and fill, for example. Then we need to make use of 3D surfaces. Okay, so having said that, I think that will be it for the lecture one. So lecture one. Remember that the percentages in terms of continuous assessment and end of semester is we are going to have, I don't know if you are aware, but there's 5% for class participation, 5% for attendance, continuous assessment is at a certain percentage. Okay, so every week I'm going to be giving you assignments on your lemma system. I hope I'm able to set it up because I've still not been able to do that. And then I'm going to set up an end of semester, mid-semester, midsummer, not midsummer. We are not in summer. Mid winter, if you like. There's nothing like that. So mid-semester exam for you, and we are going to have the end of semester exam. All that's going to be online, as maybe you are gotten used to now. Okay, so please participate, take it seriously, because in the final analysis, when I'm actually computing your final mark, then you are struggling to find marks for students. You are just pleading, like, and you're wishing that the student had just taken part in some kind of midsummer. Okay, so tell your friends who are not really taking part that, well, they are on the road to failure, and so they're gonna have to sit up. Okay, now you can ask questions, and anytime I say ask questions, is because you want to actually prove to me that you have understood. I think Israel has asked a question, and it was a very good one. It's helped him for today. You can also put in a question. It wouldn't hurt to ask it. Otherwise, I will ask you a question someday, and I'm expecting you to
My question.
answer. Yes. Hello.
My question.
Go for it. Go for it. Yes, Ivan. Go for it.
Yeah, I'm on the stone on the forestry.
Okay, Ivan. So you are the one that asked the
Complete
question.
what we
It
had
wasn't
was,
Israel. You are the one that asked the question. It wasn't Israel. Hello.
no,
Hello.
Israel was the. Hello, sir.
Israel was the one that asked the question. Okay. Okay. Go ahead. Go ahead.
No, Israel
Carry
started
on.
it. Israel
Carry on.
started the first question.
Carry
The
on.
first
Carry on.
question.
Carry on.
Yeah, so I was saying. Hello, sir.
I'm listening to you. I can hear you loud and clear.
Okay. I'm on the forestry.
Yes.
My question is, what we recently we heard that the government have, we heard that the government have bought some drones.
Right.
Drones to monitor the forestry for people cutting the trees.
To monitor the forest.
My question is, how? Yes, cutting of trees. How effective of this drone monitored?
Yes, what the drones are doing is that they are helping us to do one thing, to obtain data. Okay, I hope you are looking on the screen. So they are helping us to obtain data, and once you get a data, that data is fed into computer, which hopefully has software that then, can predict where, people are likely to cut again. Okay, so that possibility is there. It can also show you which areas have been cut in recent times, okay, and etc. So without you actually walking to the forest, because most of the time when you go there, they may harm you because they are cutting it legally and they know it, and you don't want to joke with your life. If your brother was working in forestry, you don't want them to go there. Are you with me? So the idea of data acquisition methods like that, flying drones over, is so that you don't directly go to the objects of interest. Are you okay? And also, let's not forget
Okay.
that drones taking pictures in this course is under the topic photogrammetry. So it's actually drone photogrammetry, digital photogrammetry. And so really the drones are taking pictures that are planimetric. Now it depends on the type of drone that's flying over the area. If you have a drone that can actually take overlapping pictures that are vertical pictures, you can actually generate a 3D model and you can do more than just taking a picture. But for forestry, I think taking the picture is just good enough. They don't need a height. So if they know what they're really doing, then I think definitely they are doing a very good thing. Yeah, they're doing a very good thing. Yes.
Okay, sir. Thank you.
You're welcome. Very good question. Any more questions? So definition of GIS come in three folds: toolbox definition, database definition, organization definition, and it's because of the diverse uses of GIS. Okay, I'm repeating that. The definitions of GIS are many because there are different uses of GIS. Because remember that the G stands for geography, and everything we are all doing, medical doctors, engineers, mechanics, teachers, carpenters, everything we are doing is on the surface of the earth at a certain location. So everybody will like GIS naturally. When I told my old man about GIS, he was excited. He said, well, this is very good. In fact, I told him how GIS can help the police. And he was like, wow, this is really good. All right. And so GIS as a toolbox is a powerful set of tools for collecting, storing, retrieving at will, transforming, and displaying spatial data from the real world. Are you okay? All right, so we say the real world. That means, are we living in the fake world? Not really. What we are really saying is that GIS should allow us to actually work with things around us. It shouldn't be anything that you shouldn't be imagining GIS. It should be right around you. Are you okay? So if an Uber driver is coming to pick you, let me use Uber as an example again. Some Uber drivers don't even believe it, that the app is telling them that someone is actually making a request. Excuse me. Why? Because they don't believe in the app, because the app is really like a GIS. Are you okay? So a powerful set of tools should allow us to collect, store, retrieve at will. Anytime that we want the data, we should be able to retrieve it. So in other words, I should be able to just type in, like what I did in Google Earth for you to see. Are you okay? Type in Medina, and then I hit enter, and it should take me to Medina. Where is Medina? It should just take me there. You okay? And so we have to understand that GIS also has tools to allow us to transform. Are you okay? So transform at will means transform at will. That means that we can change the data set. Okay, I can change data that I picked as points and turn them into data that looks like lines. Okay, we will touch on this again. This what I'm just talking about right now. We can have spot heights that are turned into contours. Anybody understands it, that's fine. If you don't understand it, don't worry. We'll talk about it again. But we can transform data that we have collected. Okay, and coordinate transformation and all that. And we should be able to now display the data. Are you okay? If we can't display data, in fact, then you have a problem. We can't see it. Are you okay? When you have a computer and the screen doesn't work, you have a problem. What's the problem you have? You can't talk to the computer. You don't know what the computer is telling you. So what you are seeing communicates to you. Are you okay? All right. It's like you like, being in love with a girl, and then anytime you see her, she's not looking at your face. Are you okay? Okay, no, I don't think so. That's just by the way. But with the data we talk about in GIS, really, it's not just data. It's a certain special type of data called spatial data. So there you go, spatial data. Spatial data. So spatial data is special. Okay. Another word for spatial is geographical. Are you okay? So if someone say spatial, they mean geographical. If someone also says spatial, they also say locational. So these are adjectives. Please, let's feel free and not be very rigid. So instead of saying the geographical information system, you can say spatial information system. Okay, or locational information systems. All right. So this definition is by a guy called Bureau. And he wrote this in 1986. It's been years, isn't it? Okay, anyway, so we have database definition of GIS. So what is a database definition of GIS? It says a database system in which most of the data are spatially indexed and upon which a set of procedures operated in order to answer queries about spatial entities in the database. Okay, so a database is really like some kind of drum, are you okay? Which contains, or a container, a big container in which all your data is stored. Are you okay? All right. So now when we look at it closely to the definition, then you can see that the data has to be spatially indexed actually says that an index really allows you to search very fast. Your index number helps us to find you. Is that not so? All right. Now, upon the data that we have, IOKIM, which has an index, a spatial index, we are also able to query that data. Are you okay? Now, when we query that data, what do you obtain? We obtain spatial entities in the database. So in other words, the database contains spatial entities. What are spatial entities? They are geographical entities. What are entities? Entities are like objects. Are you okay? So in other words, we can search for things within the database. So the whole GIS thing can be looked at as a database in which we have stored data in there, but the data that has been stored there is what? The spatial type of data. Okay, so their longitude and latitudes, describing location, etc. Okay, so that's the definition of GIS in terms of database. If you look at it in terms of database, organizational definition of GIS is an automated set of functions that provides professionals with advanced capabilities for the storage, retrieval, manipulation, and display of geographically located data. So you can see that it's just like the other one, geographical or geographically located data. Okay, so spatial data, as in the previous one, spatial entities, okay, geographical, okay, all right. And then the first one also talked about spatial data. Okay, so the definitions are alike but slightly different. So organizations are interested in where their companies are. Maybe we have multinationals. There are companies in South Africa. There's another company in Ghana. There's another one in the UK. There are companies that have several branches in the same city. In Accra, there are companies that we take Melcom, for example. We have Melcom in Medina, Melcom, East Legon, Melcom, Spintes. So how do we track everything that's happening in the different places? Okay, so we may want to know. Okay, so this definition focuses on something like that, and sees GIS to have, functions that does these things. What do they do? It allows us to store, retrieve, manipulate, transformation, okay, and display our data. What kind of data? Spatial data. Are you okay? All right. So this one is also by Osimoy Smith and Sickerman. All right. So basically, organizational definition of GIS, that's what it is. So after these three definitions, you can see that GIS simply allows us to really collect data, store that data, manipulate it, transform it. We should be able to query, find a way to retrieve the data that we have stored. Are you okay? And so that is what GIS really is in terms of definition. But I doubt if your exam will really, the nature of questions that are supposed to be asked, we can actually be talking about definition. But the definition only allows you to understand what it is that we are talking about. Because sometimes the answers that people give to you tells you that they don't even know what you are talking about. Okay, but let's move on. I shouldn't sound like that sentimental. Yeah. Okay, so let's talk about the components. I told you that GIS, the S is the systems. So in other words, we need to know the parts of that system. Are you okay? And the parts of it, or the components of it. Yes, another word for part to be components. So we talk about the hardware, the software, the data, the people, the methods. 5 components of GIS. And so hardware, how is hardware different from software? Are you okay? And what is the role of people in GIS? If you have a system, you can buy a fresh sound system, it will take your little boy in the house to just dismantle the whole thing, isn't it? And then you will not be getting news from the system anymore if it's a radio system you have. So people play an important role, but we talk about it. Hardware of GIS is just a computer, basically. The computer, the computer, the computer, and then other, peripherals. Okay, so in computing or information technology, we talk about the mouse, the keyboard. These are peripherals. You plug them into the actual computer. Are you okay? Except if you're using a laptop like the one I'm using, the keyboard is an integral part of the computer. Okay, the monitor allows you to visualize and to see what is happening, what the computer is actually saying. Are you okay? You talk to it, it talks back to you. And that is how it has always been since time immemorial. The keyboard allows you to make input, you type in, etc. Yeah. And so, yeah, that is what the hardware basically is. But then we'll talk about other aspects, other hardware which the GIS needs. Okay, talk about the CPU of a computer. What is CPU? What does it stand for? Central Processing Unit. The RAM is a random access memory. Not only does it have an amount of memory, yeah, for associated with the RAM, but we can also associate speed with the RAM. As you'll find out, it's not only about the memory, it's also the speed of the RAM. So if you are using, an i7 or whatever, you need to actually look at the speed at which you retrieve data from the RAM. Storage is different from temporal storage. Permanent storage is different from temporal storage. And so the RAM is really temporal. When you switch off the computer, the RAM is cleared. There's nothing on it. When you shut down, when you go in hibernation, the RAM keeps the information, doesn't get cleared. Okay. And we can talk about the motherboard housing, the processors, and okay, the BIOS and other, components of the computer that allows you to really boot the computer. So we can actually measure the processor by the speed at which it does the processing. In other words, when I do 1 times 2, how long does the computer take to do that multiplication? Are you all right? And how accurate will that be? So when you look at this one, a typical value is 1.99 gigahertz. And what does that mean? 1.99 gigahertz. What does that mean? Okay, what does the gig mean? What does the terabyte mean? What does the gigabyte? I think if you don't know it, then you need to really find out. This is basic to everyone. Are you okay? 1,000 megabytes will make, excuse me, 1 gigabyte. Please listen carefully. You know the assignments will be coming every week. So sometimes you need some of these things for us. If I ever ask you, I may not. Are you okay? 1,000 megabytes is 1 gigabyte. And then 1,000 gigabytes is 1 terabyte. terabytes. Okay, so bytes seem to be going common to everything. How many bytes? Just smashed my mouse. Wow, that's sad. Okay, anyway, hope I can. It's still working. Okay. Wow. Okay, guys, 1,000 kilobytes. What happened? 1,000 kilobytes. Yes, 1 megabyte. The megabytes. Then we can have 8 bits, megabytes, 1 byte. Okay. Okay, so the 8 bits actually represents on and off states. So you heard that computers make use of zeros and ones, isn't it? So mathematically, this is binary. Okay, so we should be able to now convert this okay into, so the 0 is off, 1 is on, 0 is off, 1 is on, and then with that we can always come back to okay the whatever it is that we are translating. So electrical to the actual data set that we have. All right, so you need to appreciate this, what I just did. If you have a question, you can ask at any time, but I expect you to understand what I just explained on the board, on the screen, not on the board. Okay, so you need a good computer. Simple. Good CPU is a good computer. Okay, and size of data, because of the size of
Feel
data.
free to get rid of the situation.
Oh, what was on the board? What was on the screen? You get it.
Yes,
You get it. I'm actually recording this for you, so you get it. It's okay. You get the video.
thank you.
So you get it. Yes. All right. So excuse me. Your graphical data is special, so we need a good computer. So you need to know why we need a good CPU. Yeah. Also, we need to query. You have data that's special. The size of data may be big. Let's say forestry. Can you imagine you're keeping all the trees in one system? So how then do you understand that? How do we make sure that we can keep all that data in one computer? We need a very good computer to do that. Okay. And then, okay, so hold on, guys. Let me look for this. I think it's taking my attention. I'm looking. Excuse me. So GIS makes use of not just the computer, but certain peripherals that helps. Are you okay? Accessories. Are you okay? These are, so one of them is, or one of the most important, accessories to a computer for GIS, a GIS workstation, as we call it, will be the digitizer. So the digitizer, as you can see there on the screen right now, is allowing the lady here to convert. It's a paper that she's placed on the board, and then she's actually holding something like a mouse, as I have here in my hand, and then she's actually clicking on what she sees on the board to be some kind of, a wadi or set of river, water bodies, yes, small streams. Are you okay? And all that. So she's converting what she has into the computer. Are you okay? In a digital form, into a digital format. Are you okay? So a digitizer board is a flat board that is used for vectorization. That vectorization is actually digitizing. Are you okay? You are converting it into a digital form. Are you okay? But then you get what we call the vector data structure, about which we will talk about. All right. So he's just doing that conversion by clicking it. All right. When you actually do digitizing by using the digitizer, you actually obtain points, and then the points, you can join the points to get lines. You can join the lines to make polygons. Okay. All right. So let's take note of that. All right. So let's move on. Talk about talk more about the digitizer. Digitizing is a transformation of information from analog formats such as paper map to digital format, as I said, so that it can be stored and displayed with a computer. Okay, we can have, two different modes, plus an extra one. We can have the point mode of digitizing, where you just click along the whatever it is. Maybe if it's a river, you select the point. You can also do what we call stream mode digitizing. In that case, you just set the computer to automatically to record, the points. In other words, but what is it really recording? It's recording coordinates. Okay, it's recording coordinates. We can have what we call the on-screen digitizing. So on-screen digitizing means that I'll be digitizing on my laptop, for example, without using the digitizing table. Are you okay? So without using this thing that the woman is sitting in front of, can I do digitizing? Yes. In that case, I have to scan my hard copy and then I'll do the digitizing. Are you okay? All right. Now, when we digitize, whichever mode that we use, we encounter errors. One of the errors is that we can have a line not reaching another line. Okay. So you have a line that is going through. So there's a line like that. And I wanted to draw another line, but it doesn't reach it. Okay. And once that happens, then I have a problem. Okay. I have a problem. You see that there is a certain gap distance from here to here. All right. So this is actually an undershoot. Okay. So apart from that, you can actually have a line that you were drawing to meet another line, but it went over it. So now you have what we call the overshoot. So we need to cut this bit off. So you need to trim this. Okay. So if you use AutoCAD, you can relate to what I'm talking about. So every engineer needs to actually appreciate how AutoCAD works. Okay, it's just basic. Every engineer needs to appreciate that. And so the concept is the same. You have an overshoot and an undershoot. You trim or you kind of snap to it, okay, to correct for these errors. So these are actually topological errors. We'll talk about topology very soon. Okay. Okay, so I think I need to clear my drawings and close this. Okay, great. So as I just said, so you can have an undershoot here. You snap it and you can have an overshoot, you trim it. So you are correcting the data and making sure, the right thing is done. Because sometimes it's a T-junction, you digitize the road, the center of the road, are you okay? And you digitize the main road, the T-junction is meeting it. Now, you are not actually having the line meeting one line meeting the other. What it means is that you have a different interpretation of what is happening on the ground. And GIS should truly represent a model reality. Are you okay? The real world, like I said. Okay, so let's move on. When you are digitizing, it's very important. Digitize as much as you can. Okay, digitize as much as you can. First, ask yourself why. Why am I digitizing? What purpose? Is it for engineering? Is it for forestry? Because the purpose will tell you how the accuracy as well. Consider what we call the coordinate system, which we'll talk about in this class. What the coordinate system is. We'll talk about this, okay, in the class. We'll talk about it. Okay. And so take note of that. Coordinate system. What is the coordinate system is really about the numbers. Are you okay? What you are recording, the numbers you are recording. X, Y, Z. Talk about it. What is the accuracy of the layers to be associated? What is the accuracy of the layers? So we talk about accuracy of layers. We talk about layers. We will talk about layers in this class. We get to know that we have to separate data into different layers. That's also done in AutoCAD, computer aided design. So take note of that. What is the accuracy of the map being used? Okay, so if you actually use the map, what is the accuracy of that map? And then, of course, when I finish the layer that I'll be joining to, what is the accuracy? You get to appreciate this more. data will be separated into different layers. What is the, okay, each time you digitize as much as you can. I've already talked about that. All right, and then only one person should work at a different, on a particular project. Don't have one person working on it. Okay, Israel will work on it, Ivan will come and work on it, Nanaya will also try some. No. When you do that, the interpretation will be different. Okay, what you see to be a road, I'll be seeing it to be something else. Okay, so I'll see it as a footpath, and so the interpretation will be wrong. When digitizing, okay, look at the source. Okay, if the source consists of multiple maps, select common reference points, whatever. Okay, so we can talk about that. Because the failure to do this could result in digitized data from different data sheets, not match. There needs to be a match. You see, the idea is that, let's look at this image here. If you are digitizing this portion, someone is also digitizing from here. The two have to kind of merge. Okay, all right. So we need to understand that we may want to merge. There's another hardware in GIS called the scanner. So everybody knows a scanner. That's what I'm talking about. Scanners are no different from what you know of. You put in a hard copy and you press a button and then it gives you a picture, or you can get it in PDF, you can get it in JPEG, whichever format that you are looking for. Okay. So scanners convert data from maps and documents into digital form, but normally you get something like a picture. Okay. As opposed to a digitizer. A digitizer is giving you coordinates. Okay. And then you can have lines and all that. That concept of points, lines, and polygons coming. Meanwhile, with the scanner, you are getting something like a picture. Okay. So what you get in the scanner is an image, more like an image. Okay, you can use different sizes of paper, A3, A2, depends on the type of scanner that you have. Okay, all right, now this is supposed to be an animation, so it's repeated from A1, A2, different size of, paper sizes. Okay, so that's not my focus. My focus is not to talk about paper sizes here. Okay, all right. Now we can talk about another accessory or peripheral to the computer using GIS is called the plotter. The plotter. So now the plotter is a printer, but can you imagine a printer that can really print on a very large sheet of paper? Okay, we call that a plotter. End of story. Okay, I don't need to explain anything. But what do printers actually do? Printers help us to really, obtain a copy of an original, especially if it is actually digital. Then we can actually print it out as hard copy, isn't it? Okay. So my next door neighbor, is a little girl, and you can hear her voice. All right. So yeah, so we can print A0, A1. You need to appreciate these days. All right. So components of GIS, we've talked about what? Hardware. The next one is what? Software. And how is software different from hardware? One is soft, one is hard. I rest my case. Please don't give such an answer in an exam. You score 0. Okay. So software is really the programs that the hardware is actually running. So when you have a computer, everything is hard. They are electronic components. Are you okay? And then you plug it and you switch it on. But once you switch it on, then you have instructions. Are you okay? These instructions are actually the programs. Are you okay? And the programs allow the user to interact with it. Okay. All right. So we have the hardware and we have the software. Hardware is different from software. The software is essential to do the generate, store, analyze, manipulate, display that we have in the definition of GIS. So the software contains the definition. It has a link with the definition of GIS more than the hardware. Every software can be looked at whether it is good or bad. In fact, I'm a software developer. Okay. Some people love my software. Some people may not find it easy to use. It can be put to a review. But every good GIS software or every good software need to be user-friendly. The user should be able to use it without asking too many questions. Are you okay? Functionality. It should be able to do the things I want it to do. I'm a civil engineer and I want to know whether I should be cutting and filling in because I'm working on this earthwork projects, And here I am with a software that doesn't do that, it just cannot do the cut and the fill for me, then it means it's not having the right functionality. Okay, every good software should be compatible. That means that it should work in different systems. Okay, it works on Android, works on iOS, works on IoT, different environments. Works on a desktop. Okay, some software don't work on particular operating systems. Okay, some software that work on Unix systems but may not work on Windows. So that is actually compatibility. Updatability, we always get updates on our phones, so I won't talk about it. Everyone listening to the sound of my voice that doesn't know about updatability, you need to be punished. Okay. Right. So updatability is getting updates. We always updating our phones thanks to technology, but that one we don't have a problem with it. But I think when we are studying and we are supposed to learn new stuff, we struggle with it. But when they force it on us, I think we take it. So when your WhatsApp is out of date, they force you to get a new version of it, updated. Documentation helps you to understand exactly how it's supposed to work, because you see, if I'm using your computer, Windows 10, and in fact, you're not even using the computer for all the things that Windows 10 has been designed for. Okay. So how many of you knew that if you actually press Windows tab and then you press Shift and you press S, you're able to take a screenshot, quickly. Okay. So right now I'm actually taking a screenshot. I don't know if you saw it, but that is how that's what documentation does for you. It tells you exactly what you're having in your hand. Okay. So there's a lot that probably your car can do that you're not aware because you haven't read the documentation. So let's learn to read. When you buy a new blender, read the documentation. Okay, don't just start using it. All right. Cost effective means that when I introduce software, I don't care what it is, it's business. Everything, like someone will tell you that everything is business. So it needs to now help me to cut down costs. If it's not doing that, forget about it. I don't want to know what you're talking about. That's what technology does. Introducing technology to an organization should help the organization to increase their turnover. All right. Okay, so that is what good software should do. It should come in to, to help me reduce my cost. These are examples of software, and remember that I told you about the one that we'll be using in our practical. We'll be doing a practical. We'll be using what we call the quantum GIS. Okay, so all of you, this is the first week assignment, which I didn't put on the lemmas because I couldn't access it. Please, you are supposed to install the software, and I will inspect it very soon, and I'll give you marks for that. Install the QGIS and wait. When the time is up for us to use it, I'll tell you, then we use it. So Quantum GIS gets the latest version. Always get the latest, get the stable version. That's, let me see that. Get a stable version. All right. So that is that for software. Yes, go for it. Hello. So go to Google to install it. Google QGIS stable version.
Yeah, I've downloaded it.
Please, I'm asking you to do it. So just do it. There shouldn't be any question. Stable version. Okay. Download it. Install it. Please, it's an assignment. I want you to do it. Nobody has done it yet. Even if you have done it, you haven't done it. I want you to now go and do this. Okay? This assignment. Okay, this assignment one. I'll put it properly on the lemmas so that you can do it. Download QGIS stable version. Okay? Go to Google and get it. So go to google.com. Get QGIS stable version. Download it. Install it. And then you'll be a happy man. Is that okay? All right. Great. Do that for me. Let me move on and talk about data. So data is not information. Okay? Data is not information. But data is very important. Without it, we can't have information. Is that all right? All right. We can collect data ourselves. We can just choose that we want to collect data. We can buy it too. Is that okay? We can purchase data. All right. Oh, these kids. I think they know I'm talking here. Anyway. So data attributes, what are data attributes? Data attributes, we're talking about what kind of data do you have? Are you okay? So in other words, I can give you examples right now. So let me give you 3 types of data. This is data. Okay. This is data. Okay. And we can also have data. This is data. I don't know what happened. Okay, this is not even a proper date. So okay, you can have this data degrees, but they are all not the same. Are you okay? You can have, I'm saying Medina because that's where I am. Please don't come here. You can come here if you like. But basically, these are 3 different types of data. Okay, and they can be put on a scale. Are you okay? We can actually measure. Are you okay? Them. And so, if this were, let me just say, this were money. So this is Ghana cedis or something like that. Then we know that if you have twice as much as I have, if I have 1,000 cedis and have twice as much, there's a relationship, okay, between the values. Israel is also a type of data, but this data is just a name. It's just like a label, okay. All right. So we need to understand the difference between this type of data and this type of data. All right. Because if we're going to be collecting data, then we need to know the type of data that we have collected. Okay, guys, hold on and let me close this window. I know we are finishing, isn't it? Yeah, we are almost done. In fact, let me run up. I'm going to talk about, this is going to be the last topic I'll talk about. Then we continue the next time. Is that okay? All right. So this type of data where I can talk about the interval, are you okay? Between, like I said, 1,000 and 2,000, there's a relationship. Are you okay? There's a difference between the two values. So that data is called interval data. Data that is like names, like labels like this, you call that nominal data or the nominal scale. Are you okay? So you are using the nominal scale. This one is interval data. Okay, this is date. We can decide whether date is interval or nominal, but date is likely to be interval. Are you okay? Then we can have what we call ratio data. So ratio is data that has an absolute 0. Are you okay? So data that is interval doesn't necessarily have to be ratio. Are you okay? So, but once we introduce an absolute 0, then we know that we are dealing with ratio data. Is that okay? All right. So, example, you can have 4 degrees, but actually 0 degrees doesn't mean that we don't have anything. 0 degrees, you can actually have minus 4 degrees. Okay. So when we talk about data, we have data in there are different, types of data or scale, or what we call data attributes. So another word for attribute is what? Property. Are you okay? So we are talking about getting data and telling what type of data do I have, the kind of data that I have. Okay, so Medina will be nominal. Are you okay? So we can have nominal, interval, ratio, and then we can also have a type of data which is more like road classes, are you okay? Or soil classes. So soil classes, if you are class A, are you okay? So this is a type of data, class B, that we can collect. Okay, so this one is called the ordinal data. Ordinal. So we are measuring on the ordinal data scale. The data attribute is ordinal, nominal. We can have interval data. So you should be able to tell whether data is nominal, that is a name, interval, if the intervals make sense, ratio, if it has an absolute zero. Okay, so temperature is interval and not ratio, but weight is actually ratio data. Okay, so this is actually coming from statistics, but we need to know, once we are talking about data, we need to know. Okay, all right. So that is that. We are ending the class on this one. Okay, we are ending the class on this one. So these are different data attributes. The different data attributes. Okay, have the nominal, the ordinal. Okay, place names, street names are nominal. Have interval and ratio. Temperature is interval. Weight is ratio, like I said. Then we can try other ones. So you can just try it yourself if you want to find out if data is what. So then when we meet again, we talk about the other components of data of GIS, which is actually, I think I'm feeling hungry now. People, and then what again haven't we talked about? In fact, we even talk more about data. I think there's more to talk about data hierarchy. Yes, we need to recognize that data is actually the raw facts hierarchy. Data has to be collected accurately. Okay, if data is not accurate, if you had a red car last year and you don't have it anymore, then collecting that data, it has to be relevant. That data that you collect has to be relevant. So data has to be relevant, etc. Okay, and so we'll continue. Generally, today's lecture has just touched on what GIS is and probably what you think it was and what it isn't. Okay. And we've looked at definitions of GIS, why we need GIS, okay. We've even tagged on a few areas of application apart from civil engineering. So you can see that we didn't even talk about GIS in civil engineering, okay. So this class, the focus is on civil engineering, how it can be used. But in the outline, I told you that one of the last topics I'll be talking about will be road networks or networks, okay, use of network analysis, okay, and then 3D surface designs. There are other concepts of GIS that we talk about that we can apply in GIS, in civil engineering. So I hope you followed it. The different components of GIS, which is hardware, software, data, people. In fact, the last one is methods. To be continued another time. I'll touch on the rest, and then we'll move on. Okay, on to other topics. You can ask a question if you like, because we still got time. Today, Zoom has been very generous. They're just giving us a free, we say, no 40 minutes limit. So I think we are very good. If you have a question, you can ask. If you don't, then I think we will end the lecture here. Okay? Yeah. So since no one has a question, I think we'll end it here. Please feel free and contact me about any issue you have. Don't wait till the last minute. Then you start making calls. Yeah, calling me on my phone. This is the time, okay, that I can actually explain things to you. Not at the end of the semester or the middle of it, please. So take care. Enjoy the rest of the weekend. And yeah, God bless you. Bye-bye.
Yes, sir.
Yes.
Said.
Yes, Ivan. Is it Ivan?
Sir, please, I'm trying to